Sorry for that. Now, let's start now. I think the second relationship that you're going to learn is relationship between two or more continuous variables. Yeah, thank you so much, Faith. So the relationship between two or more continuous variables. And this type of analysis that you're going to use is what we call what? Correlation analysis. Now, before we get into that, let me explain a few things about correlation analysis. And I kindly request that you have a pen and a paper and or a book, or rather a book where you're going to write on. Now, anytime you want to run a correlation analysis, you normally look at three things. So anytime you want to run a correlation analysis, and kindly don't write this, but this is something I want you to note. Now, whatever I'm going to state here has nothing to do with the steps. You remember the steps that you are talking about, whereby you have to identify the type of test, the confidence level, those 5 levels. So kindly don't confuse. Whatever I'm explaining here is only related to correlation analysis. So anytime you want to conduct a correlation analysis, you normally have to look at 3 things. Number 1 is the strength of the correlation. Number 2, or rather B, is the direction of the correlation. And the last one, which is C or 3, is the significance of the correlation. So I have said, anytime you want to run a correlation analysis, you normally look at the 3 things: the strength, the direction, and the significance. Now let me explain about the strength of correlation, or rather what it means by the strength of the correlation. Now, anytime that you are running a correlation analysis, you're going to be getting a result of a value that we normally call a correlation coefficient. So I'm actually discussing about the strength of the correlation. So under that, anytime that you'll be running a correlation analysis, you're going to get a result of a value that we normally call a correlation coefficient. Now, what is this correlation coefficient? Now, the correlation coefficient is just a value that you're going to, or rather, this is the correlation coefficient is just a value that is going to assist you to interpret the strength and the direction. So the correlation coefficient is just a value that assists you to interpret the strength and the direction. We're going to see all this, so don't worry. So for example, if you conduct this type of analysis, the correlation analysis, and in your analysis, the correlation coefficient is 1, then we normally, in that case, we normally get what we call a perfect correlation. So if you're going to conduct a correlation, and in that case you get 1, or rather value 1, then we normally call it a perfect correlation. So this is what it means. For example, this is just an example. If you are to take you and yourself, that is you and yourself, you are actually perfectly correlated to one another. In simpler terms, I mean that you and yourself, you look alike. You, Jonathan, you and yourself, you are look alike. That's what now I mean, that you are perfectly correlated. So whenever you see a value 1, when you are conducting this type of analysis, it means they are perfectly correlated. They are look alike. Sorry for that. Now, if you find a correlation coefficient And I hope you are you are writing this down. So I've said if you get a value 1, that one is perfectly correlated. So that's a lookalike. Now, if you conduct now another analysis and you find a correlation coefficient of value 0, so value 0, then here you say there is no correlation. So value 0 equals to no, 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 no correlation. Now, no correlation means that you are not related by any chance, by any way. You are not related. So you can see here that value 1 is perfectly correlated. Value 0, you simply say what? It's not related by any chance. Again, if you conduct another analysis and you find a correlation coefficient that is between 0, 0, and 0.5, so you perform a correlation analysis and you get a value that is in between 0 and 0.5. We will call that kind of a correlation coefficient, we're going to call it a weak correlation. So you're going to call it a weak correlation. And remember, value 0 is not part of weak correlation. So note that it's between 0 and 0.5. And 0, it's not part of that weak correlation. We have just said that 0 is no correlation. So it's between 0.1 to 0.5. It is weak correlation. I hope you are together. If I'm too fast, kindly let me know. Thank you. Thank you. Now, again, if you find a correlation coefficient that is between 0.5 to 1, that kind of correlation coefficient is known as strong correlation. And remember, the 0.5 and 1 are not part of strong correlation. I hope you are noting that. So you can put into brackets for the strong correlation, it's actually 0.7, 0.8, 0.9. That's where the strong correlations falls. For weak correlation, it's actually 0.1, 0.2, 0.3, 0.4, 0.5. For perfect correlation is value 1. For no correlation is value 0. I hope we are together up to that point. Now, what we have just discussed is what we call the strength of correlation analysis. That is the first thing that you are going to look at, the strength of the correlation. Now we move to the second one, which is the direction of the correlation. Now, as far as the direction of the correlation is concerned, then it can only take two directions. Can only take two directions. So you are either having a positive correlation or a negative correlation. So as far as the direction is concerned, it can only take two directions. So you can either have what we call a positive correlation or rather a negative correlation. So let me explain what is positive and negative correlation in a very simple way that you can relate to. Now, sometimes, normally, you're going to realize that, for example, if the demand of something is going high, what happens to the price of that item? Also, the price of that item goes up. So the demand for people who are consuming is still the same, but you see the supply is maybe, in another case, you might find people are consuming something and the demand is still the same, but the supply has become less. So what happens to the price of the item? it actually goes up. I remember there was a time the price of onions was so high because of the price was high because there was low supply from the farmers, but the demand was still somehow high. Again, uh, we can actually let me rephrase in a much easier way. For example, what happens when the price of a commodity goes up? You'll find that the demand actually goes down because if you go maybe to buy something like a bread, and maybe you find that maybe yesterday you bought it at 100 shillings, but today you go to the shop and they're saying at 150. What will happen? You'll decide to buy what? Maybe a mandazi or something that will be able to supplement whatever you want. So there'll be no demand for bread. That means what? If the price goes high, the demands comes down. So you are seeing here what's happening. Uh, the two things are moving in different direction. So the price is going high, the demand is going down. So this is what we call what? A negative correlation. It means that one thing goes up and the other one goes down. So that's what you could refer to as a negative correlation. In positive correlation, maybe you can have an example like if the supply is very high, it's because also the price is maybe high. So here we are seeing that one goes up and also the other one goes up. Now that one is what we refer to as a positive correlation. So for the negative correlation, you have one thing goes up and the other one goes in the opposite direction. So they are moving in opposite direction. That's what we call a negative correlation. For positive correlation, the same things move in the same or in positive correlation. One thing is going up and the other one is also going up. So this is now in direction that is the explanation as far as is concerned. The third thing, still in that, is the significance. So as far as the significance is concerned, we only need to look at the p-value and compare it with the alpha value. And this is something we have done. So you go to the table that is going to be already we have analyzed, and you'll be able to do what? To see that. Now, the p-value, you actually get it after doing the analysis. But what about the alpha value? The alpha value, you already have it. You remember we said that we're going to use a confidence level of 95% when it comes to analysis. In the field of very sensitive parts of medicine like surgery, we use 99%. But for analysis, generally, it's used what? 95%. Now, after getting the confidence level of 95%, we remain with 5%. The 5%, we convert it into a value which will be equivalent to 0.05. So in significance, what you do, you now compare between the p-value and the alpha value. After comparing, that's when now you come back to your hypothesis, which you actually formulated. That is the null hypothesis, which will always show there is no relationship, and the alternative hypothesis, which will show that there is a relationship. And that is where now you'll be able to come up with your conclusion. So correlation analysis always, or rather involves looking at what? The strength, the direction, and the significance. So any question up to that point, because I want us to get into practicals. Any question up to that point? Any question? Are we good? Uh-huh. Okay. So in case you get lost anywhere, kindly let me know. So let me share my screen So I'll kindly request that we all of us let's open the employee data table. McKenna, do you have the employee? McKenna? So McKenna, do you have the file? Okay, Faith and Kyoko, have you managed to open your files? The employee data file that we used yesterday?
Opening now.
Thank you. What about Kyoko? Yeah, so I'm saying in case here you have data type as string, so I want you to come and click here, transform. I want you to click on transform. Or I think the best way, because mine is okay, I'll kindly request one of you to share the screen, kindly. I think that will be the best way. Going to change that data type from string to numeric. Main reason being SPSS cannot or will only analyze data in numeric data type. So I want you to click on transform. Faith, I want you to click on transform. And then there's what we call record. Now record means changing one data type to another. Now you can see there are two, the record into same variables and record into different variables. So let me explain before you click. Now, record into the same variables means what? You're going to do it there. What will happen? You're going to make changes to that number 2, gender. So you're going to make changes there. But if you click on record into different variables, it's going to add it below it. Itakuja hapo number 11, add another row with the same information for gender, and it will not interfere with the first one, ile ambayo iko kwa number 2. So what is your take? Do we perform the 2 so that you understand quickly, or you can just do 1, or we do the 2? Thank you. So I want us to start with record into different variables. So click transform quickly because of time, and then click onto different variables. Just click it. So let's wait. If Kyoko, you can be able to see that. So I think you are able to see a window called record into different variables. Is that what you're saying?
Yes.
Okay, thank you. Now, Faith, I want you to proceed.
Yes.
I want you to proceed. Just leave the screenshotting. I want you to proceed. And you have a table there: employee code, gender, date of birth. Now, what do we want to record? This is actually the gender. But I don't know why I'm not able to see. You are saying you shared the whole screen. You have the data type Evo. Yeah, click on it. What are you seeing as the umeambiwa male is equals to? Click on the click hapo kando. Hapo good. So what are you seeing there? That what is equivalent to male?
I am, sorry.
A capital or small?
Small.
Very good. What about the female?
Small f.
Small f.
Small f.
I want you to note that. So if it was indicated a capital F, you're going to use a capital F. If it was used as small, make sure you maintain that. Good. Now let's come back again now here. So I think you had clicked on transform, then record into different variables. So click on the gender, transfer it into the output variable. Record into different. So have you clicked on record into different variables? So I want you to transfer the gender to the output variable. Good. Now, just below that output variable, there's what we call old and new values. Old and new values. Old and new values. Are you able to see that? Now, you are going to have two sections. The first one is the old value and the new value. Now, the old value, let's start with male. What was the old value? It is m. Sawa sawa. Small m. So andika kwa old value small m, and the new value will be 1. I hope you are using the small. Are we together? Kindly just unmute. Don't worry about the background noises. Just kindly just unmute. I want to make sure you're doing the right thing. Thank you. So we have said, once you input the small m in the old value and 1 in the new value 1, click add. You're using that option for add. Let's use the emoji.
Yeah.
Let's go to the second one is small f. Small f. Small f. And then the new value will be 2. And then you add. Now in that window ambayo imeandikwa old, then ikaonyeshwa arrow new, you're supposed to have something M1 and then F2. Are you seeing that? Then click on continue. Click on continue. Have you clicked on continue? Good. Now you come here to what you call the output variable. The output variable. Here, since you said you want to record into different variables, you're going to come up with a new variable name. So what are you going to write there? You can actually, I don't know, are you closing, Faith? Or what am I saying? Okay, so you have to come up with a new name because you said into different variable. So you just write gender 2. And remember variable names. Faith, are you lost or I'm seeing something? I'm seeing you're trying to struggling doing something.
Yeah. I am. I think I closed the wrong tab.
Okay. So Faith, this is what you're going to do. You actually come here, record into different. You place it here. You come to old, new. So after inputting the old and the new, you click continue. Then actually you're going to click on this change. I cannot repeat it because I've already done it. So you click. Okay, is that okay up to that point? Thank you. Then now this is when you record into a new or different variable. So I want you to kindly just click here for number 11, and then you can right click and clear. I want you to remove that row. So I want us now to use the code into the same, into the same variable. So we go through the same procedure. So now we want now to change this one here, upper. So what do? We click on transform. I hope you are together. Record into the same variable. Record into the same variable. Record into the same variable. Then click on the gender. Gender is the one that you want to change the variable. So we say record is where you are changing a variable uh, to another. Sorry. When you want to change a data type of a variable. And remember, I said never come here and just change it straight away. So what you do, you come to transform, record into the same variable, then place the gender into here. Then we just use the same formula. Click on the old and new values. Click on the old and new values. What was the old values for male? Is a small m. Kindly don't change. Don't use a capital M. It will not be able to identify it. Then you come here and put 1. After that, you click on add. Thereafter, you come here, you put a small f, and then here you put 2. And it's not always the same. You can use any digit, but for uniformity, let's just use the 2. Then you click add. So are we together up to that point? Then from there, after having those values there with their new values, I want you to click on continue. And someone might ask, we don't have that option for name and the that option that we're having here. Why? It is because we are actually editing an existing variable. So there's nothing that we are going to change here in terms of the name of the variable. So after that, the OK is now active. It's still OK. It's active because you are not doing it into a different variable. So after doing that, I want you to click on what? OK. I want you to click on the OK. So what do? What happens? You see, after doing that, this is now when you come here. So after doing what you call record into the same variables, after doing this, after performing this, that's now when you come here. Now come here now on the data type here, click on it, and then come and change what? The data type. So kindly, as I said, first of all, perform a record. After performing the record, that's when now you come here. That's when you come here and click on numeric. Are we together up to that point? Are we together? Sorry, I think Jonathan has left. So can you give him a few seconds to come back? Thank you. So kindly let's, yeah, good. Jonathan, I think you have an issue with the internet, but you're going to continue. So are we together up to that point?
I'm following you.
Thank you. So I've said after performing the record, this one, let me just repeat it. That's when now you come here to change. So what are you going to change? We are going to change it into numeric data type. And then you click on OK. What message do you get or warning? Some value labels or missing value specifications will be discarded for gender. And since we had already changed the values and we already have the values within the file, what do? You click on OK. Sawa sawa. You click on OK. Now, what are you going to notice here? What happens here? You will see that here changes to what? None. Meaning that it's now giving you an option to do what? to input the new values. So I want you to come here to values and make sure if hata zenu pia ni inaonyesha none. Yes. So I want you to click on these three buttons here and then now start inputting. So value 1, we said value 1 is for male. Then you click on add. Then value 2 is female. Then you click on OK. Oh, sorry. So kindly don't do the same mistake I've done. I was too quick. So you put value 1 for male, value 2 for female. So are you to get up that point? If you are okay, click on OK, and now you are good to go. Then on the same table, I want you to change on the width. Make sure it's at least 8 for everyone. For every variable. Just change it to 8 or even 10, but not be below 8 because you can put it to 10. You can put it to. Make sure they are all 8. So that's something we had learned. If you can go back to the recordings that we had, you would actually find this. Okay. Then from there, you can actually go to educational. You have another error there. In education, you should be able to have scale. Then employment. Yeah. So I think you've now understood what I wanted you to learn. Sawa sawa. Yeah. So let us now come back to what we are supposed to learn. And here, we were actually supposed to do a type of analysis known as what? Correlation analysis. And here, we want to do a correlation analysis and see if education, the relationship, education is the relationship between education and salary. So we want to see the more maybe you are, sorry. It's a bit of confusion. Kindly just allow me to confirm something. Yeah. So we want to see education and relationship to salary. So how do we do this? And the kind of relationship, the analysis that we want to use is what we call the correlation analysis. So let's begin and see the relationship between education and the current salary. That what happens, the more education you have, does it really affect your current salary? So what do you do? Remember the steps. You have to identify the type of the analysis to perform. You have to come up with the hypothesis and follow until the fifth steps. So what do? You click on analyze. After clicking on analyze, I want you to click on correlate. Once you click on correlate, I want you to click on bivariate. Sorry. I want you to click on bivariate. Then, since you want to see the relationship between education or education its relationship with the salary, so I want you to choose on the education. And then you click it so that it moves to variables. Then the current salary. So are we together up to that point? So are we good up to that point? Thank you. So
Sorry, I got a little distracted.
Oh, okay, okay, okay.
I am so sorry. Yeah,
No problem, no
kindly if you
problem.
don't mind. Yeah.
Let me repeat. So as I was saying, let's now come and do the practicals on relationship between two or more continuous variable. And the type of analysis that we're going to use here is correlation analysis. And before I continue, I say that when you are doing correlation analysis, you have to look at the strength, at the direction, and at the significance. Now, how do you perform this practical or come up with, sorry, how do you come up with the analysis? And the analysis that we are going to do, we want to compare two things: education um, to its relationship with the salary. And also we are going to see the salary comparing it with the experience. So what do you do? For you to perform this kind of correlation analysis, you come to analyze, correlate. We have correlate, then bivariate. Then we'll have this table here. So what are we going to look? What are two things, two continuous variables that you are looking at? So the first one is actually what we call the first one that we have identified is the education, and to its relationship with the current salary. So as you can see here, these two are what? Are what we call what? Are continuous variables. Then from there, we're going to leave the Pearson the way it is, and the uh, two tile or rather two-tailed, two-tailed kind of command. So I want you to untick the flag here, the flag significant coefficient, and untick that. So we are going to use the Pearson because we are looking at the normal distribution of data here. So just leave it that way it is. Yeah. And what is normal distribution of data? I've said you're going to use the Pearson option because we are dealing with, or we are looking at the normal distribution of data. Well, so what is this normal distribution of data? It actually means that you are using a sample to represent a population. So whenever you are dealing with a sample uh, to represent a whole population, you will always be using what? Pearson. So, for example, if you want to do a research on how this country is being governed, I think this research you usually see it in TV. What happens? You're not going to do a research with each and every Kenyan. So the only thing that you're going to do, you're going to pick a few counties like Nairobi, Nakuru, Mombasa, maybe Kisumu, and then out of those counties, you're going to use those samples to represent the whole of Kenya at large. So in that case, where you're going to use the few counties that are mentioned, like for example, 5 counties to represent 47 counties, then you'll be required to use what? The Pearson. Then, okay, let's go back. That was just a small explanation. So I want you to click on OK. I want you to click on OK. So now let's see the correlation. So we have this table here. You're going to see that I'm going to remove it. Now, let's look at the table. Now, let's interpret the table that we have here. Now, the first thing that we look at is the strength. You remember the strength that we are talking about? We have the perfect correlation, which is equal to 1. You remember that? Then we have the weak correlation that is between 0 to 0.5. And remember, 0 is no correlation. And then between 0 and 0.5, it's the weak correlation. And 0 being excluded. Then 0.5 to 1 is a strong correlation. 0.5 and 1 being excluded. Now, the first thing, let's look at the strength and then the direction. So we normally combine the two when it comes to interpretation. Now, let's start with the education here. If you look at the education level here, if you look at the education level here, you can see it is perfectly correlated by this value. So you can see here, the education level in years is perfectly correlated to education here. Are you seeing that? So education level is perfectly correlation, look alike. That's what I mean. Then, if you look at the education now here, I hope you are seeing my screen. I'm not talking to myself. So I hope you're looking at the screen. And I hope you have the same analysis. If you are, yeah, thank you. Thank you. I have to, the reactions from McKenna and Kyoko, kindly. I don't want to lose you anywhere. Thank you. Thank you. Now, if you now compare, we have said the education level and the education is perfectly correlated because they are look alike. Now let's compare the education level and the current salary. The current salary. What can you see there? We can see the current salary is at what? 0.0661. Where does it fall? If you can remember. Someone to unmute. 0.0, sorry, 0.661. Where does it fall? Someone to unmute kindly. Kindly just say it. If you get it wrong, we are going to correct each other. It's better when you try it, you'll always remember it. Someone to unmute? Anybody? Uh-huh.
Strong correlation.
Perfect. Strong correlation. That is strong correlation because it's falling between 0.5 and 1. So this is, so we can see here, the correlation coefficient that we have here is strong. So we can see that it lies between 0.5 and 1. So this is a strong correlation. Again, this value 0.661 doesn't have a negative. Ama ya nani iko na negative? Is there anyone who have a negative? I don't think so because you have the same data. So if you look at this value here, it does not have a negative. And you know that any value that does not have a negative is a positive value. So as you can see that as one thing goes up, the other one goes up. Basically, what does it mean? That as the education goes up, also the current salary goes up. And therefore, we will interpret this, we are seeing, okay, therefore you are seeing here, we are actually interpreting the strength and the direction at the same time. So we're going to, so up to that, we are going to say that education in years and the current salary are positively correlated. That when one thing is going up, the other one is also going up. Sawa sawa. Then the second thing is it is stronger. So you can see here the strength that it is a stronger correlation. So we normally say there is a strong correlation, or there is a strong for strength and then positive for direction, and the correlation between the education level, so we can say there is a strong there is a strong correlation for strength, and then there is a positive correlation for direction between education level and the salary. So we can actually put it this way: there is a strong positive correlation between education level and the current salary. So are we together up to that point? So we can actually conclude that there is a strong positive correlation between education level and the current salary. And remember, those are only two things that we have just touched on. Remember, there was a third thing still on that. That was called the significant. So the last part we have to look at is the significant. And the significant is very easy. What do? We actually compare the p-value to the alpha value. Remember, the alpha value will always be constant. That is 0.05. So for us now to compare, we said the p-value, you get it after doing the analysis. So here is our p-value, which is 0.01. So, and the alpha value is 0.05. Remember, we already had our hypothesis, the null hypothesis, which always shows there is no relationship, and the alternative hypothesis, which show that there is always a relationship. So if we compare now the two to get the significance, we are going to do what? We are going to compare the p-value and the alpha value. And the hypothesis, when you are comparing, we always say that when the p-value is less than the alpha value. So in our case here, we can see 0.01 is less than the alpha value of 0.05. So once you get such a statement, what happens? We are going to reject the null hypothesis, which says that there is no relationship. We are going to reject that null hypothesis, which says there is no relationship. And we are going to conclude that there is a relationship between education and the salary. Then quickly, we're going to now to just do this another analysis, the same on correlation, whereby we are going to compare current salary with the total experience. So let's do another example. So I want to go back to analyze, correlate, and bivariate. So we are still on that. So what I want you to do, I want to take back the education because we still want to use the current salary. I think I will have to go fast kidogo because I want us to touch on the next, so that next session we have time to finish. So take it back the education, then remain with the current salary, and then look for total experience, or the previous experience, then take it there. So are we together up to that point? I think I hope I'm not too fast. Are we together up to that point? Thank you. Faith, and McKenna, to make sure you're okay. So I think at our variables now we have the current salary and the previous experience. Thank you. So just go and don't change anything. I think the flag is unchecked. So the only thing you're going to do, you click on what? Okay, to get your analysis. And there you go. You'll be able to get it. Now remember the first one we already interpreted. Yes, Faith.
I can't see the current salary place because I have clicked correlate, then bivariate, but then I can't see how to change. I can't see how to take the experience and the salary.
Okay, can you be able to see my screen?
Yes, I can.
Now, does your table actually the previous experience
Mm-hmm.
is actually here down just before
Oh,
this?
previous experience.
Yeah,
Okay.
I think I'm the one who make a mistake. Pole for that. Sorry,
Okay.
apologies for that. So you should be able to get current salary and the previous experience. Now, I think the only thing you're going to do, just click on OK, because already the Pearson and the two-tailed is. So click on that. So you're going to see, don't worry, mine has 3 tables because I've repeated. You'll be able to get, I hope you have not repeated. So we close this so that, Yeah. So I think okay, don't worry. I'm having only one table before because I closed the other one. So I think we are together. You are having two tables. Just use the below one. Don't worry, mine is one. I think I've closed because I can confuse you. So are you together up to that point? Are you able to see this table? All of us. Now let's start now analyzing the table. So yes, Faith.
There's a problem still.
Uh huh. Uh huh.
I clicked on the current salary and the previous experience,
Yes, and then
but
you
then
click.
the education level is still in
Oh,
that table of variables, and I
click
don't know how to
click
remove
on the
it.
education. Click on the education.
Uh-huh.
Then there's that arrow in Aonesha. You are
Or to remove.
yeah. Thank you.
Okay.
Uh huh. And after doing that, I think you'll be able to have two tables. Be able to have two tables. The other one, and so I think you're okay right now. Faith. Thank you. Now I want us now to analyze the second table. Don't worry, I have only one because I closed the other one. So let's now start analyzing. So you can see that the current salary is perfectly correlated to the current salary, which is 1. But when now you come to the current salary and you compare it with the previous experience, now what is the first thing that you're seeing there? The first thing that you see there, let's start now with the strength 0.97. Okay, let's assume first the negative. So already we have a negative there. So 0.97, where does it fall? Maybe someone? McKenna, you have not spoken this class. Where does 0.97 fall between okay, let me not see. Okay, just try. Anybody who can assist McKenna? 0.97, where does it fall in terms of strength? What do you call that?
It is a strong correlation.
No. Zi-
0.97.
0.97.
So
Is
there
it?
is a negative star. It's
Uh,
true.
Good trial, good trial. But is it really? So I think it is actually a weak correlation. 0.09 is actually a weak correlation because it falls between 0 and 0.5. It actually falls between 0.05. Now, to make it easier for you, for example, if you are to round it that number to 1, Jonathan, and all of us who are in class, you will find that maybe to round everything off to two decimal numbers, that 9, it will fall here iwe 0.1. Are you seeing that? Are you now relating, Jonathan?
Yes, I got you.
Yes. So it is actually going to fall under weak correlation because itakuwa kama ni 0.1. So I think now that's so clear. So that is a weak correlation. Now we come now to the second one, which is negative. Sindio? So it is negative correlation. So the first two things you have identified is it's negative and it is weak. Sawa. Then that is the strength in terms of weak and the direction in terms of negative. Then the significance, the last one, let's see at the p-value. The p-value here, this two-tailed. But actually, I forgot to tell you, for you to get this, the p-value, angalianga tu hii significant tailed, utaiona hapo. So let's look at our p-value. Now, the p-value is always equivalent to this a sig two-tailed here. So what are you seeing there? It is 0.34. So we said if the p-value is less than the alpha value, which is 0.05, we say that we reject the null hypothesis, and therefore we conclude there is a relationship. But now, as you can see here, our p-value is too big. It is too big. Actually, it is it is actually 0.34. This is a very big. Sorry, it is 0.034. It's a very big value. So what is happening here? We are actually seeing that the p-value is high. Or anytime, let me make it easier. Anytime you see that the p-value is closer to the alpha value, now here you fail to reject. You don't accept. Sawa, there's nothing like accepting in analysis. You fail to reject the null hypothesis, and you conclude that there is no relationship between the two variables. So you fail to reject. You don't accept. I hope that is clear. We don't have anything like accept. We will fail to reject the null hypothesis. Is that clear up to that point? Is that clear up to that point? So again, if I may repeat, if you are having a okay, Jonathan has left. So if you are having a very small p-value, then the higher the relationship. So if the p-value is less than the alpha value, then you reject the null value, and therefore you conclude that there is a relationship. But when it comes and you have a higher value, or the p, or you have a p-value that is closer to the alpha value, you fail to reject. You fail to reject the null value and conclude that there is no relationship between the two variables. Now, from here, what will be our conclusion here is that there is no relationship between the current salary and the previous experience. Why? One thing you're going to what you're going to come here is that you're going to say the current salary, when comparing with the total experience, you're going to say it is a very weak relationship. It's a very weak relationship because you can see that there is no relationship. Is that clear up to that point? Now, I have a question here. Looking at this data, and you are working at this organization, will you rather increase your education level or maybe add experience? Which one are you going to work on? Maybe someone to answer? Which one are you going to work on?
I think education, because there was a strong correlation.
Yes, there was a strong positive correlation. Thank you. But when it comes, the relationship between the education and the current salary, we actually came up with an analysis and saw that there is actually a strong positive correlation between the education and the current salary. But when again we come now and compare the current salary and we compare it with the total experience, we see that it is a very weak, in fact, it's a very weak negatively relationship, because we have seen that the significance here, that the p-value is too high, or it's closer to the alpha value. Now, any question up to that point? Any question? Any clarification? Any clarification? I thought maybe we'll be able to do another analysis, but I think for the interest of time and also maybe digesting what we have learned, is it okay for us if we can stop here? I need your input on that. You are only remaining with one session. Yes, thank you. So I think we're going to stop here as far as the second relation. I think the second, is it the second one? Yes, the second one.